Okay, so today we're talking about chemical stability and the octet rule and the periodic table. If you've taken a chemistry before, this part might be a little bit of review, but if you haven't, that's okay. So when we look at the periodic table, this is my lovely hand-drawn periodic table. I know it's not perfect, but it's what we're working with. When we look at the periodic table, we notice that there are rows that go this way and columns that go up and down. Now the columns in the periodic table we're gonna call groups. So I'm gonna go ahead and change this arrow to a red one. It's a color code. So our columns are groups. And each column tells us how many valence electrons we have. A column over here has 1 valence electron, and a column over here has 8. Now, our rows go across like this, we call periods. And periods tell us the number of orbitals that the atom has. The higher up on the periodic table the row is, the fewer number of orbitals it's going to have. As you go down, you'll have more. So the octet rule tells us that elements will lose, gain, or share electrons to obtain a complete valence shell with 8 electrons. So the key word here is a complete valence shell with 8 electrons. Well, we just talked about how over here we have 8 valence electrons. So as you go across through different columns, you're also going to increase how stable the atom is, because you have more, I don't think I spelled that right, but it's okay, because you have more valence electrons. So columns on the left are going to be less stable than columns on the right. This last column is the only one. So this column right here is the only column with 8 valence electrons that is completely stable. To talk about this lose, gaining, or sharing part, how atoms become stable, watch our video on chemical compounds.